Okay, there we go. So let's list some strategies on taking limits. How's that?
Sounds great.
Okay, so the first step with limits, can you see while I'm writing like this? So step 1, so evaluating limits, yeah? I'll change the name here to evaluating limits. Step 1, straightforward plug in. So try to plug it in. Try to plug x in. And I mean plug, the value of x. If it works, that's it. If it works, we're done. Okay? So this is always the first approach. Example on this. Okay? Like, for example, the limit of x minus 2 over x minus 3 as x goes to 1. Okay? So first we try to plug it in. Watch. So whatever there's an x, put 1. So this becomes 1 minus 2 over 1 minus 3. 1 minus 2 is minus 1 over minus 2. So that's half. So the limit is half. So that means anytime you approach, anytime x approaches 1, the y approaches half. That's what the meaning of the limit is. So graphically speaking, it means when x, like let's say the graph is here, whatever the graph is, doesn't matter. Okay. When x goes to 1, so let's say 1 is here, okay, the y gets closer to half. That's what it means. This is the x-axis, this is the y-axis. Okay, so that's step 1. Okay, now, step 2. Okay, if it doesn't work, by plugging in, try to simplify. Now, try to simplify. Simplify could mean many things. It could mean factor. Okay, and this is mostly what we did, is we tried to factor it to get rid of the... oh, by the way, when I say if it doesn't work, why wouldn't it not work? Because it would make your denominator 0. And in math, you can't have a 0 denominator. This is not acceptable. Okay. Okay. I'm going to try to... Yeah.
Okay.
I'm not sure why. This never happened.
Oh. Teams, a lot of times they're wearing like stuff with their team.
Okay. So that's fine. I mean, if you don't mind people hearing. So yeah. So the reason it doesn't work is because you get a 0 in the denominator. Okay. So in math, you can't have like a 0 here. That's not good. 0 on top is fine. So when I say it doesn't work, that's what I mean. Okay. So let me actually write this down here. So doesn't work means 0 in denominator. How's that? Okay, so back to what you do. So what you do is you can factor, you can simplify, to make it go away, to make that term in the denominator that's giving you the 0 go away, or you could, because I by the conjugate. Okay, so let me just call it rearrange because we haven't done it anyways. And from what I've seen, I don't think you'll have that. So example on what I'm saying here. Okay, so this is step 2. Like for example, let's take an example. Let's say you are taking the limit of x squared minus, let's say 8x plus 15. Okay, over x minus 5 as x goes to 5, for instance. Okay? Now, if you try to plug in 5, you're going to get, watch, clearly you can immediately recognize the problem here because you have 0 here, and you're also going to get 0 in the numerator. 25 plus 15 is 40, minus 40 is 0. So you're going to get 0 over 0. You don't know what that is. You can't do it. So this is no good. So then you factor. So 5 and 3. They both have to be negative because that's minus. So you get x minus 5 times x minus 3 all over x minus 5. And then this goes away, as you can see. This was the source of trouble, the x minus 5. And it went away. So now what you have left is the limit x minus 3 as x goes to 5. So now you go back to strategy 1. You just plug it in. Yeah. So then, because now there's no more 0 in the denominator. So this is 5 minus 3, and you get 2. So the answer was 2. Another example on rearranging to get the limit to work. Let's say you were taking the limit. Let's say of x minus 7 over yeah, minus x plus 7 as x goes to 7. Step 1, plug it in.
Right, 7 minus 7 is 0. Negative 7 plus 7 is 0.
So that doesn't work. Okay, so now look, if you think about it, this is a source of trouble.
This is times negative 1.
Times negative 1. So you could pull out a minus 1 from here, factor out a minus 1 from the bottom. Or if you want, if you could just say, I could multiply here by minus 1 and here by minus 1, whatever you like. Which one you prefer?
Let's multiply by minus 1.
Yeah, so then you can multiply here by minus 1. But then you'd have to do it here as well. Okay? And then when you do this, this becomes minus x plus 7 over x minus 7. Okay. Right? But you still get 0 over 0. You see what I'm saying?
Yes.
So maybe that wasn't the best step. Then I just let you see it for yourself that it still didn't get you anywhere. So maybe it's just better to factor. So what are we factoring? A minus 1. To turn this exactly into that. So we get minus x minus 7. Do you understand why it's minus 7?
Yes.
And then here you have x minus 7. And now look what happens. So you get negative 1. So the limit will just be negative 1 because there's no more x to plug in 7. Okay. So those are examples. Let's now go to strategy 3 or step 3. Okay. If step 2 didn't work, if factoring didn't work. Take the sided limits. Take side limits. What I mean by that is, I mean evaluate as x goes to a minus and as x goes to a plus. Whatever it is. So should we do an example on that?
Yes.
And then if these two are the same, let me continue writing the rule. If the two limits are the same, meaning the limit as x goes to a minus and x goes to a plus are the same, then that limit is the answer. Meaning, maybe if we put it in a diagram, it's better. So let's say you are taking the limit of f of x as x goes to a. Okay, and you're using this strategy. You take the limit of f of x as x goes to a minus, and then you take the limit of f of x as x goes to a plus. So we're summarizing here in a chart, okay? And now let's say that the answer here was, L, and the answer here was L. If they're the same, therefore the limit of f of x as x goes to a is equal to L. Okay, if those two numbers are the same, like this is a 5 and this is a 5 or whatever. If they are different, the limit does not exist. So, limit of f of x as x approaches a equal DNE. DNE means does not exist. Okay? Let's take examples on this. So, yeah, let's say we want the limit. Let's say f of x equals x minus 3 over x minus 5, and then we want the limit. Let's just write it right away. We don't need to write it fast. Yeah, keep the questions simple and concise. The limit as x goes to 5. Makes sense? Okay, so strategy 1, plug it in. Doesn't work. You get 0, right? So if you plug it in, it doesn't work. Try to factor. Dead end. There's nothing you can factor. Go to the sided limits. So, right? So plug in, no good, because you're going to get 0. So this is no good. Plug in doesn't work. Can't factor. Correct? Can't simplify. Can't cancel. Okay. So do sided limits. What should we do?
So since the limit is 5, so we do 4.99.
Right. So we take. Right. So we take the limit as x goes, let's go at it from the left, so that's 5 minus, so yeah, that's 4.999. So then we plug in 5 minus here, minus 3, or actually first let's just try that as x, and then we'll put it in. So this was x over x minus 5. So put the 5 minus in, so we get 5 minus 3 over 5 minus 5. Now, like you said, 5 minus is 4.9999, right? So that's 4.999. Right, so we end up with 2 over 0. Infinite amount of zeros. It's very small. Infinite amount of zeros. Because it's 4.999, infinite amount of 9, subtract from 5, you're so close to 0. So infinite amount of 0 is 1. So what's 2 divided by 0.00001? Now, if you remember the strategy, I showed you this. Let's say you didn't know what this is. Okay, start with them one by one. Say, what's 2 over 0.1? You get 10. 20. What's 2 over 0.01?
So it's going to be 2
you
infinity.
Get 200.
So this is going to end up being, right?
Exactly. If you add 2 zeros, look, all of a sudden, you're growing so quick. 2,000. So this is going to be an infinitely large number.
Infinity, right? Because, because there's 2 times infinity is not bigger than infinity. It's just still infinity. It's more infinity. Right?
Because when you divide, the number is going to grow very, very large.
Right.
Yeah. 2 times infinity is infinity.
It's just infinity.
Yeah. Let's do it from the right.
Okay.
So let's grab that. I think this laptop is acting a little weird because it was in the sun.
Oh yeah.
And it was on. Well, in the car.
Right. Yeah, it gets hot.
So x goes to it gets hot 5 plus because usually it's much nothing than this. So we get fx minus 3 over x minus 5. Okay. So 5 plus is a little bit past 5, a hair away from 5, bigger than 5.
Right.
So this is going to be 5 plus minus 3 over. So 5 plus would be 5.000001, infinite amount of zeros 1, a hair bigger than 5.
Right.
So 5.000, infinite amount of zeros 1, minus 5. So we're going to get 2 over. What's 5.00000, infinite amount of zeros 1 minus 5?
0.00000.
Same thing.
Right.
Oh, wait.
No, it ends up just
wait. Yeah, this is correct. But here we forgot the minus sign.
Okay.
Because the 5 was bigger.
Oh, okay.
So in fact we are getting minus infinity, not plus infinity.
Minus.
Sorry about that. Yeah. You understand why?
Yeah.
I mean, it's the same explanation, but you have that minus sign, which makes you minus infinity. Okay, so here we are getting a positive number, but very small. So it's same thing as that, except because 5.0001 is a lot larger, is a bit larger than 5, so we get 0.00, infinite amount of zeros, 1. And the answer is
2 over
0.000, infinite amount of zeros, 1. The answer will be
2 over 0.000.
Yeah, so the answer will be just like here, infinite.
Oh, infinite. Oh,
yeah,
right.
Infinite. Okay, so here we got minus infinity, here we got plus infinity. Therefore, the limit does not exist. The limit of x minus 3 over x minus 5 as x goes to 5 does not exist. Does not exist. Okay. Now, this is not always the case that you don't get a limit when you do the sided limits. There are times where it does work out, depending on what the answers are. Okay, so these are basically the strategies with the limits that don't involve infinity. Okay. That's it. Should we do another one? Okay. Yeah.